welcome you all for the online classes of hydraulic subject. So in the last video I had briefed you about the definition of fluid mechanics, classification of fluid mechanics, applications of fluid mechanics, as well as the principles of fluid mechanics. So today in this video we will study about the definition of fluid and the types of fluid. Okay, so fluid or liquid, it is defined as any material which has the tendency to flow. Characteristics of liquid is it has no definite shape and confirms the shape of the vessel into which it is poured. So the definition of fluid or liquid, okay, so any material which has the tendency or ability to flow is known as fluid or liquid. Okay, so here to briefly define the definition, so any material means example water. So it is a matter. Water is nothing but a matter which exists in atmosphere. Okay, so water is a kind of material which possesses the tendency to flow. Okay, it has the properties that if water finds a slight slope also, it starts flowing. Okay, so one more example is oil. Okay, oil, it is also a type of liquid which also possesses the tendency or property of flow. Okay, so these two are the general examples for fluid or liquid. And the characteristics of liquid is it doesn't has any shape. So water, it is not having any shape, or oil, it will not have any shape. But when we are pouring water into a vessel, for example, if we are pouring the water in a circular jar, then the shape of the water will be circular. If we are pouring it in a rectangular jar, the shape of the water will be rectangular. If we are pouring it in a square jar, the shape of the water will be square. If we are pouring it in a conical flask, the shape will be conical. So the characteristics of liquid is it is not having any definite shape, and it conforms to the shape of the vessel in which we are pouring the liquid or fluid. So this is the definition of fluid or liquid. And in the next topic we will study about the types of fluid. So coming over to the types of fluids. Fluids are classified into following types. Number one is a real fluid, second Newtonian fluid, third non-Newtonian fluid, fourth ideal fluid, and the fifth one is plastic fluid. So these are the 5 types of fluid. Sometimes this question will be asked in the exam, define fluid or liquid and list the types. It may be asked for 5 marks, and sometimes the question will be list the types of fluids and briefly explain. So you have to list the types. It is one by one you have to write down real fluid, Newtonian fluid, non-Newtonian fluid, ideal fluid, and plastic fluid, and then you have to briefly explain in a sentence or two. So to brief you about the types of fluids, the first one is a real fluid. So real fluid means a real practical fluid is one which has viscosity, surface tension, and compressibility in addition to density. Real fluids exist in nature. Okay, so what is a real fluid? Real fluid means it is a fluid which has viscosity, surface tension, and compressibility in addition to density. Okay, so here, so what do you mean by viscosity, what do you mean by surface tension, and what do you mean by compressibility? Okay, so here one by one I will explain you. So viscosity means it is a property of a fluid. So viscosity means it is a property of a fluid which offers a resistance to shear. Okay, So now what do you mean by resistance to shear? So to explain you people in general, I will give you one example. Okay, so consider two fluids. Okay, consider two fluids. One we will take as water, the other one we will consider an oil, any oil. It may be coconut oil, it may be engine oil, or any other oil. Okay, we are considering two liquids, one is water and one is oil. So if you pour both the liquid material, water and oil, from two separate pipes, okay, so both will come down with certain speed, but water, as it is having zero viscosity, okay, its speed will be more considered to oil. So oil, it is viscous in nature. Viscous means it is thick. Okay, because of its viscous nature, it offers resistance to the surface of the pipe. Okay, that is called as viscosity. And the next is surface tension. Surface tension means it is the another property of a liquid which enables it to resist tensile stress. Okay, so this is the another property of a liquid. And compressibility means it is also a property by virtue of which fluids undergo a change in volume under the action of external pressure. So here, as I told, viscosity means it is nothing but in general you can tell the thickness of the liquid. Okay, so water, it is having zero thickness. If you feel the water, you cannot feel anything, but at the same time, if you feel the oil in between your two fingers, you can feel something viscous. Okay, that is, the oil will be having certain amount of thickness, that is called as viscous, because of which the oil offers resistance to the surface of the pipe. Hence the velocity of flow of oil will be less compared to velocity of flow of water. And compressibility means it is the property by which the fluid can be compressed. Okay, if we are applying external pressure, external force, the fluid can be compressed into a container. It may be a jar, it may be a bottle, okay, it may be a tin. So that is called as compressibility. So real fluids, they exist in nature. Hope you have understood the definition. So moving over to the second one, that is Newtonian fluid. Okay, so Newtonian fluid, it is a real fluid in which the shear stress is directly proportional to the rate of shear strain. Okay, so Newtonian fluid means a fluid in which shear stress is directly proportional to shear strain. That is called as a Newtonian fluid. Okay, so here, in other words, the rate of deformation varies linearly with shear stress. Okay, so in general we can define this Newtonian fluid as any fluid which obeys Newton's law. Okay, any fluid which obeys Newton's law is called as Newtonian fluid. And here we have already studied in SOM what is shear stress, what is shear strain. So stress is nothing but load by area, and strain is nothing but the deformation caused due to application of the load. So any fluid in which the shear stress is proportional to shear strain, that type of fluid is called as Newtonian fluid. Next is non-Newtonian fluid. So this is also a real fluid in which the shear stress is not proportional to shear strain. So reverse of the Newtonian fluid. If the shear stress is not proportional to shear strain, so that type of fluid is called as non-Newtonian fluid. The fourth one is ideal fluid. So ideal fluid, it is the fluid which has no viscosity and surface tension and is incompressible. Ideal fluids does not exist in nature. However, fluids which have low viscosity such as water and air can be treated as ideal fluids. So earlier in the first definition I had told you, so water, it has zero viscosity, means it has no thickness. Okay, so it will not offer any resistance to the surface. Whenever you are trying to flow the water from any surface, the surface may be a PVC pipe, it may be a cast iron pipe, or it may be a soil pipe. So whenever you pour the water through the pipe, the water will readily flow if it finds a slight slope also. That is why the example for an ideal fluid is water and air. It also, if you pass the air from any pipe, the air will pass from one side to another side without any obstruction. So that is why water and air, these are considered as ideal fluids. Next one is plastic fluid. In the case of plastic substance which is non-Newtonian fluid, shear stress is more than the yield value, and also shear stress is proportional to shear strain and is known as plastic fluid. So here plastic fluid. So plastic fluid means we know the three matters: elastic, plastic and gaseous. Okay, elastic, plastic. So elastic means any material which regains its original size and shape, and plastic any material which will not regain its original size and shape. So here also plastic fluid means it is the fluid which is non-Newtonian, means here the shear stress is not proportional to shear strain. Okay, the shear stress is not proportional to shear strain, but the shear stress is more than the yield value. Whatever the yield value will be there, the shear stress will be exceeding the yield value, and such type of fluids are called as plastic fluids. Hope you have understood the definitions of fluid and types of fluid, and in the next class we will deal about the second part of the introduction chapter, that is measurements of fluids, and what are the methods and instruments used in measurement of the fluids.